Integration is a great tool for working out area, but it does have a flaw, and that flaw is that it can give negative answers for areas. So this, if you use integration to work out this area, I'll make this concrete. That's y equals x squared minus 2x between 2 and 0. Integration will give you a negative answer for that. I'll give you an example. I'll use this example here. Okay, so that's no big deal. We just say the area is 1 2/3. Okay, so I call it a flaw, but you might say it's not that much of a flaw. Well, in fact, it is a flaw that's big enough for you to have to be very careful with it. Let's just do a very simple example. This is going to be the simplest curve of all. It's just y equals x. And I want to work out the area as far to the left as -1 and as far to the right as 2. Now this is so simple that we can actually advance what we're going to get. That is an angle of 2 and height 2, so half the base times the height is 2. That is a triangle of base 1 and height 1, so half the base times the height is half. So the area of this is clearly 2.5. But what happens if we do our procedure on it? Stick the algebra into the curve, indicate how to the right and how far left you want to go. Now you do your thing. And now write it twice. So that's 2. So it's given us the wrong answer. Now what's happened is it's treated this as a positive area and it's got an answer of 2. It's treated this as a negative area because it's below the x-axis, and it's treated that as a -1/2, and it's added those two numbers together, and that's where 1.5 has come from. But in fact, what you should do is not add 2 and -1/2, you should add 2 and +1/2, and then you get the correct answer of 2.5. Now what does this mean for you? In other words, how should you cope with this flaw? Okay, well what it means is see if there are x-intercepts, and not just x-intercepts, I'm talking about genuine crossings of the x-axis between your endpoints. Okay, so for example, if I was working out the area of this, so the area of that between, say, -2 and 3, you've got to see whether there are any crossings of the x-axis between -2 and 3. So that's simple enough, just find some intercepts. Oh, in fact, this couldn't really be any worse. There are 3. Okay. This is an example of where being good with graphing helps you a great deal. Oh, this really couldn't be any worse. When I say couldn't really be any worse, I mean there couldn't really be any question that involves any more work. You basically got to work out those 4 areas and add them together. So work out this. Get an answer, store it in your head. Work out this. Get an answer, don't store it literally, store the positive version of it because that will give you a negative. Work out this. Store it. And finally, work out this. Write it down, or rather don't write literally what you get down, write down the positive version of it and add those 4 things together, and that will be your final area. So your final area will be 4 areas added together, 2 of which are literally what you got out of the integration process, and 2 of which are not literally what you got, but rather the positive version of what you get. So that's how to handle this flaw in the integration process. What it means is that before you work out an area using integration, you must check to see if the curve crosses the x-axis, because if it crosses the x-axis, you will be adding together a positive and a negative area together and you'll be getting the wrong answer.